Welcome to GWA Physics, and today this problem that we're going to work with deals with the conservation of energy and springs. In many of the problems that we've worked on in class, some part of the problem involves springs. And so in this situation, you can see that I've got a spring with a block sitting up against it, very much like a pinball machine. And the K value for the spring is 220. And we're applying a force initially in the direction to the left of 25 newtons. And what we're trying to find out is, how is the energy in the spring going to be related to the velocity of the block after the energy has been transferred? So the first thing we need to do is we need to establish the two formulas that we need to use. One of them is called Hooke's law, which is F equals Kx. The second formula is that the potential energy of the spring is equal to 1/2 Kx squared. Now, from the information that's been provided, we're going to start with Hooke's law. So we have 25 newtons is equal to 220 x. So we're going to divide both sides by 220. This one canceling, and x will be the distance that it has stretched in meters. Hold on, I'll get a calculator. So 25 divided by 220 is 0.114. So x equals 0.114 meters. Now, the next part of this problem involves the potential energy in the spring. Let's work that over here on this side. The potential energy in the spring is equal to 1/2 of Kx squared. The x value is 0.114, and we're going to square that, and then we're multiplying it by 1/2 of K, which is going to be 110. So 0.114 squared times 110 is 1.43 joules. Now that's the energy, the potential energy, that's stored in the spring. Now when we let go of the block, the energy that's in the spring is going to be transferred to the block, and when it's transferred to the block is going to go sliding to the right at some velocity. Now, the velocity of the block is going to be based on its kinetic energy, and kinetic energy is equal to 1/2 of mv squared. We've got the mass of the block at 0.5 kilograms, so 1/2 of 0.5 is going to be 0.25 kilograms right there. And the energy is going to be 1.43 joules. So we're solving for v, or the velocity, the speed at which the block is moving. So we're going to take 1.43 divided by 0.25 and then take the square root. And the velocity is going to be 2.39 meters per second. So that block is moving to the right at 2.39 meters per second. And that is how those conservation of energy problems work with springs. Thank you for watching.